Hello my dear students, in this session we will discuss Newton's formula for speed of sound and Laplace correction for it. Okay. What Newton thought is, Newton thought that the propagation of sound wave in air is an example for isothermal process, means the sound waves, we know that they are longitudinal waves, they move in the form of compressions and rarefactions. In that process the temperature is constant, that is it is an isothermal process. Newton thought that propagation of sound waves in air is a isothermal process. So, what he did is he took the equation of isothermal process, that is PV is equal to constant. Now, this equation, if we differentiate this equation with respect to volume, what happens, we will see differentiation of PV with respect to volume is equal to differentiation of constant. So, we know that differentiation of a constant is equal to 0 and this we differentiate like this, it is UV rule, first function, this is first function, this is second function. So, first function into differentiation of second function V plus second function into differentiation of first function is equal to, we know that differentiation of a constant equal to 0. So, this dV by dV is equal to 1. So, what happens? Pressure P is equal to minus V into dP divided by dV, or what can be done, this V can be taken to the denominator. So, what happens? Pressure is equal to minus dP divided by dV by V. But we know that from mechanical properties of solids chapter, we know that this is bulk modulus. So, this is equal to bulk modulus. In general, we know the velocity of sound, equation for velocity of sound is V equal to square root of bulk modulus divided by density. Bulk modulus is divided by density. In this case, we have proved that bulk modulus is equal to pressure, or what happens, equal to square root of pressure divided by density. Here, if we use the standard values, what are the standard values? Pressure equal to 1.013 into 10 to the power 5 Pascal, and density of air is equal to 1.29 kg per meter cube. If we use these standard values, we will get an answer for velocity of sound V equal to, roughly it is 280 meter per second. You can see the calculations, but experimentally we know that velocity of sound is equal to 332 meter per second at standard temperature and pressure. So, this is the experimental value. This value, so we got using Newton's formula. So, there is some small discrepancy in this. Something has to be corrected there. That correction was done by Laplace. What correction he has done, we will see. Now, we will see Laplace correction. What Newton thought, I will write here. What Newton thought is propagation of sound is a isothermal process. What Laplace said is the compressions and rarefactions will happen so fast that there is no time for the excess heat to propagate to the environment. So, it is a adiabatic process. According to Laplace, the propagation of sound waves in air is adiabatic. It is adiabatic. So, what he did, he took equation for adiabatic process. What is that? PV to the power gamma is equal to constant. So, this is the equation of adiabatic process. Now, we will differentiate this with respect to V. Differentiation of P V power gamma is equal to differentiation of constant we know that differentiation of a constant is equal to 0. So, here there are two functions. Okay. First function into differentiation of second function, okay, plus second function, this is second function into differentiation of first function. So, this is equal to 0. Now, we will simplify this a little bit. So, what is differentiation of v power gamma? It is in the form of differentiation of x power n into x power n minus 1. So, what happens? P into, okay. So, gamma into v power gamma minus 1, okay, plus v power gamma into dp by dv as it is, that is equal to 0. Now, what we will do? We will move this v power gamma into dp by dv to the RHS. So, what happens? P into gamma into v power gamma minus 1 is equal to minus v power gamma into dp by dv. Now, we will simplify this. We will move this v power gamma minus 1 to the RHS. You will see what happens. P gamma is equal to, okay, minus v power gamma into dp divided by dv, okay, and this v power gamma minus 1 comes to the denominator divided by v power gamma minus 1, simplification. Now, when it goes up, what happens? P gamma is equal to minus v power gamma, okay. This the power gamma minus 1, when it goes up, it becomes minus gamma minus 1. So, when the power goes up, it becomes minus into dp by dv. We will do some simplification here. What happens? So, minus v, okay, to the power gamma. So, this is minus gamma, okay, minus of minus plus 1, minus gamma plus 1. So, that gamma and gamma gets cancelled. So, v power 1, okay, or it is just v, okay, into dp by dv, into dp by dv. So, what happens? P gamma, I will just write it once again. It is minus v to the power 1 means we can neglect, okay, v power 1 into dp by dv. Now, what we will do? We will bring this v to the denominator. So, what happens? This implies P gamma is equal to minus dp divided by dv by v. We know that this is bulk modulus. So, therefore, bulk modulus is equal to P gamma. Now, what is the equation for velocity of sound? Velocity of sound is equal to square root of bulk modulus divided by density. Here bulk modulus is equal to P gamma, okay, P gamma divided by density. Now, for air, okay, for air value of gamma is equal to 7 by 5, okay, I will write here value of gamma is equal to 7 by 5, value of gamma is equal to 7 by 5. So, value of pressure we know. So, here we have already written pressure is 1.013 10 to the power 5, density of air is 1.29 kg per meter cube. So, if you substitute all those values here, you will get the answer approximately 331.2 meter per second. This in close agreement with the correct value of speed of sound. Experimental value of speed of sound is this 332 meter per second. So, after doing the correction, after Laplace correction, we got the answer exactly equal to, almost equal to 332, that is 331.2 meter per second. So, this is Newton's formula for speed of sound and Laplace correction. So, what is very important to know? Newton thought that speed of the propagation of sound waves in air is isothermal process. So, if we do the calculations, we are going to get speed of sound as 280, okay. Then that 280 is not equal to experimental value. Then Laplace did some correction. What he told is the compressions and rarefactions are so fast that there is no time for the transfer of heat to the surroundings to make it isothermal. So, it is an adiabatic process. Then we have to consider equation of adiabatic process. When we derive, we will come to know that bulk modulus is equal to P gamma, and if you substitute the value of gamma for air, gamma value is 7 by 5. If you substitute, you are going to get an answer 331.2 meter per second, which is almost close to the experimental value at standard temperature and pressure, that is 332 meter per second. Thank you.